John for Year 13 Physics, Mechanics and Linear Motion, and today's lesson is lesson 6, which is dealing with circular motion. So the way I state circular motion is we look at the type of motion that is caused depends on the unbalanced force and which direction is that unbalanced force acting. So in the first one, you have an object that is moving forwards and the unbalanced force is in the same direction as motion. So what's going to happen is this object is going to speed up. The second example, the unbalanced force is opposite the direction of motion, so that's going to cause the object to slow down. And in the third example, the unbalanced force is at 90 degrees to motion, and that is the result of this sort of thing is circular motion. So circular motion is when an object is traveling in a circle at constant speed, its direction is always changing, so its velocity is changing. Now, a change in velocity can only be caused by a force, and this force acts at 90 degrees to the direction of motion, so it has no component in the direction of motion. So what the force does is that it does not change the speed, but it changes the direction of motion. This force is directed towards the center of the circle, and it has a special name. It's called the centripetal force. Now, an unbalanced force always causes acceleration, and the direction of acceleration is the same as that of the unbalanced force, and therefore it acts towards the center, and this is called centripetal acceleration. So here's your circle with an object going around the circle. These are all different parts of the circle. This is the direction of the instantaneous velocity. As you can see, it's changing the whole time. The centripetal force and centripetal acceleration act at 90 degrees to the direction of motion at that instant, and it's directed towards the center. There are a couple of formulae associated with circular motion. So acceleration is v squared over r, and unbalanced force is ma. So m times the formula for acceleration. In case you're not given speed but you know the distance and the period, then you need to use this. And over here, what is it that provides centripetal force? So if it's a ball on a string, it is the tension force. If it's planets going around the sun, you've got gravity force. And if it's car on a horizontal road, it's a friction between the tires and the road. So when you have a horizontal flat curve, that's where you have all the forces that's acting on something that's moving on a circular path horizontally. So the gravity force and reaction force balance each other, and so your friction is what contributes towards your centripetal force. Okay, however, you can't always rely on friction to provide centripetal force. You could have conditions where your tires are bald or the road is icy, and so that could be dangerous. So what we do is we kind of lift the edge of the road so that it is at an angle to the horizontal, and these are called banked curves. And so for your banked curve, the horizontal component of the reaction force, this one, is what provides the centripetal force. So over here, the reaction force and the gravity force are no longer the same size, and the reaction force can be split into the vertical component as well as the horizontal component. The vertical component of the reaction force balances the gravity force, and your unbalanced force is the horizontal component of the reaction force, which is Fr sine theta, and that provides your centripetal force. And here's a worksheet on that about banked corners with an example. So often you're asked to draw the forces that's acting on a car or something. So the forces are your gravity force. Make sure you show that it's vertically down by showing it's at 90 degrees to the horizontal. and your reaction force is 90 degrees to the surface. So that's your 90 degrees. And I have resolved that into its horizontal and vertical components, and you can go through this worksheet. I've worked it all out for you, and there's your answer.